Hello everybody, I am Ananda Hota. I will be speaking on the talk titled Red at Home India, a collaboratory model of citizen science research. I am a UGC faculty at PMDA Center for Excellence in Basic Sciences, Mumbai, India, and Director and Principal Investigator of Red at Home Astronomy Collaboratory. I am a member of IAU, International Astronomical Union, Cyclometer Array, Astronomical Society of India, Principal Scientific Advisor to the Government of India Consultative Group. Formerly, I was associated with ISC, NCRA, ACIA, AYUCA, ISA Berhampur. Let me just briefly outline the abstract that I have submitted. It is just to read so that everything is concise in a minute. Red at Home is a nationwide inter-university collaboratory of professional astronomers, trained citizen scientists, and technical engineering administrative facilitators. The only Indian citizen science research platform in astronomy. Nearly 30 institutes and similar number of professionals have contributed to its growth since 2013. In a flying pyramid model, scientists and facilitators are its wings. A large number of trained citizen scientists, key astronomers or eye astronomers, at multiple levels of expertise, make the multi-layer pyramid. There is 150 E astronomers, 1,000 Y astronomers, 2,500 active learners in a total group of 4,700 members. This way, citizens achieve geometric telescope time, co-authorship in papers on galaxy evolution, and MS or PhD selections abroad, or all-round growth. So, I'm not going to give a citizen science introduction, but especially I would refer to Annual Review of Astronomy and Astrophysics, the paper Ideas for Citizen Science in Astronomy by Marshall, Lintott, and Fisher. There they have described Red at Home, where it is kind of a program that it doesn't require a custom-built infrastructure to continue such a project. Recently, Cyclometer Array website also highlighted us out of 7 radio astronomy projects, where they describe how we involve undergraduate science students and citizens in orienting them to GMRT research, black hole galaxy evolution research, and ultimately towards SCAR Pathfinder. GMRT is SCAR Pathfinder. Here in this slide, one can see that various things has been put here. That the Red at Home trained citizen scientists are located in different parts of India. It focuses on science with giant microwave radio telescope. It has been supported by various institutions, including international like IAU, OAE, and OAD, highlighted by Nature Index, ICTP programs, and SCAR. So what I mean to say that all these institutions that have been put here at various level of involvement, they have supported the growth of citizen science. Some have posted our training program, some have posted us for small talks and selected our result presentations, etc. And it's certainly without fail, we need to acknowledge the support from late Professor Govind Swarup, who is considered father of Indian radio astronomy. He wishes us all the best and directs us on how to find quickly gems from the GMRT images. Similarly, because of this interesting, innovative, and successful socio-scientific experiment Red at Home, I've been felicitated by directors of ISER, Kolkata, and Berhampur. ISER is a Indian Institute of Science Education and Research, which does undergraduate education as well as research. I have been awarded Samarth Chandrasekhar Jyotirvigyani Samman and felicitated by the Chief Minister of Government of Odisha. Why is it? What have we done? What have we been doing so that institutes are attracted and public authorities are also appreciating? This is the summary. That summary is in 5 points. That we simply have a website. We simply have a Facebook group. We simply conduct various discovery camps in various institutions all over India, hosted by them. Then from these activities, we make pre-discovery reports, and that is followed up with GMRT telescope. So this is kind of a flying pyramid model that we conduct astronomy education, outreach, and research at the homes of different citizens, undergraduate students. That leads to development. So right hand side top shows the website. The Facebook group is on the left with 4,000 above members, and the small group that goes to the discovery camp training. So they basically are peak, and large number of people try to grow. This is what is the camp. Some 10-20 people can be trained for 7 days extensively and ready from discovery camp at ICTS Bangalore. We certify them after this training. That helps their career growth, applying to different places. And larger number of people in 1 day or 1 weekend online interaction, 50 to 100 people can be trained. They become eye astronomers. Extensively trained for a week are E astronomers. These are called eye astronomers. Larger but less extensive training. And then this is why actually when it is in this kind of hierarchy, a lot of people are getting involved. The government and government authorities are getting interested in this in the sense that how to involve large number of people in and orient them, excite them to mega science projects that the government is preparing for. So in numbers that we have, I am only one PI or director, but there are 30 institutes supporting, 30 scientists are contributing, 150 trained for 1 week, nearly 1,000 trained online or 1 day, 2,500 active learning in Facebook group, and 30,000 in contact through STMP. What we do, how active this is shown this way. There is a Facebook group. There are on average 2.6 posts, 30, 20 comments, and 40 reactions every day, averaged over 1 year. What do they comment and discuss? What do they post? They post various galaxy images. What do they achieve through this discussion? They get selected to this training camps for 7 days. They get selected to MS and PhD programs abroad. This is how they grow their career in Facebook participation in some sense. What exactly they do? They participate in 2 activities mostly. Daily Galaxy RGBC. Depending on the month and day, they discuss different galaxies. In a 1-day program, they discuss based on their location, pin code, different new galaxy RGB image analysis. We have a simple RGB maker tool, which is Python based, getting the data from NASA Skyview, where they simply put their name, the galaxy NGC name or something, and they get the images, multi-wavelength images. What do they get in multi-wavelength images? What kind of images? They get this kind of UV, optical, IR, radio, multiple images they make. And they go beyond the constellation knowledge of stars to how radio outflow from galaxies actually work and understand stars, young stars, old stars, dust component, stellar component, black hole plasma outflow, etc. They are told that make radio images and look for non-standard sources, faint fuzzy sources. Once they found interesting faint fuzzy sources, they will be followed up with the GMRT. They will propose that's how we have got 50 hours of GMRT time. And that is how we have been almost whatever they discover basically preliminary report they submit, and they can become co-author in multiple papers with professionals, of course, led by the professionals. Here is what is the direction they are aimed at. What they are aimed at? They are aimed at black hole galaxy coevolution by merger, feedback, etc. When they are discoveries, they can make faint fuzzy sources like this. They can see that their objects they are analyzing is part of SCA brochure, and there is interest. It's highlighted by many press releases. This kind of thing excites them. They want to discover something to be part of that. As a summary, I can discuss that we welcome all kind of people assigned to astronomers to become co-author, astronomers institution to host our program, and this is how we want to grow that way.